So, hello everyone again and welcome to my channel. In here we're going to be looking at the Diels reaction, and in here now we're going to be looking at intramolecular reactions. Before we looked at the intermolecular reaction, which is involved between two molecules, but in here we're going to look at reaction within a molecule. And now this is done in the presence of heat. So if you implement heat, not photo heat or photochemistry, we're going to arrive at a nice 4+2 rearrangement that leads to the formation of a double bond actually being formed over here. But on this other point, you are transforming 3 double bonds into just 1 double bond with the inclusion of 2 sigma bonds, which are this over here and that over there. So these are the 2 new sigma bonds that are being formed, and is a result of this 4+2 rearrangement over here, or cycloaddition. And in here it's going to be fascinating for we to explore the regioselectivity and the stereochemistry of our particular products that are being formed. One thing you need to know about the regioselectivity is due to the number of lobes that are present over here. We have 2 lobes. This is going to be the lumo at some point, and this other side is the homo at this point over here, and pretty much the homo and the lumo are going to interact at some point because the homo has electrons in its second state, and what that happens then is that you're going to have an orbital overlap between this particular orbital and that orbital, because both of them are in phase, but this and that is out of phase, but this and this is in phase with each other. So the orbital overlap will be pretty much this. So this one overlapping with that, and while this overlapping with that. So what that is that you're forming a bond because the homo donates electrons, because this is a diene species in this particular segment of this molecule, and this is a dienophile species within this particular molecule file. So what we got here is that it's pretty much the regioselectivity of this particular reaction that leads to the formation of that. However, we're going to be also looking at the stereochemistry, and the stereochemistry proves that this is actually an endo product. So this endo product is as a result of the interesting overlapping of orbitals due to the dipole-dipole interaction within this particular functional ester group and this particular pi system over here, so that therefore there will be some kind of rotation in bonds that lays this particular segment underneath this particular segment over here. So if you look at this molecular model kit over here, let me zoom this out. Yeah. So what we have over here is we have this double bond, which is this particular point over here, and this double bond over there is the segment with these 5 carbon atoms over here, and we have these 6 carbon atoms over here, which is what we have over there. So as we get closer, we then introduce you to the pi system, where in here we have this double bond that has been in this position over here within this 5-membered ring over here, which is what we have over there. And over here we have the other double bond, which are actually cis to each other, which is what we have over at this point over there. So this region, which is here, and this at the bottom over here, is a rotation of this particular bond, which lays it downwards, and you see here is pointing downwards, which is away from me over here. And in here there is the rotation of the bond, which is this bond, which lays this oxygen at this point over here to be moving this way. And then you have this particular group pointing within this particular segment over there, and over here we're going to have our hydrogen pointing up over here, and then we have our other double bond over here. You see that? And in here we have our chloride or chlorine atom over there, which is pointing in the cis position. So these particular bonds are all positioned in the cis position, and that will lead to the nice orbital overlap within this particular carbon and that carbon over at the bottom over there, and this carbon over here, thereby forming sigma bonds here and sigma bonds over there, thereby making our product to have our chlorine pointing up, which we have over here, and we have our hydrogen over here pointing up, which we have over there, but our ester bond is pointing downwards, which we have over here. So therefore this will arrive at our final product, which is an endo product, and this is also as a result of the dipole moment that makes this particular ester to interact a little bit with this dipole or with the pi system over here, so as to make the transition states to be thermodynamically stable, and this will enhance the formation of the sigma bonds between this atom and that atom and this atom and that atom over there. So this is just a molecular model interaction or simulation of what you got to expect, and now let's draw it. Now the drawing is going to be quite interesting because I'm not too much of a good drawer, but let's just go at it. Give it a shot, because that is chemistry. Well, anyways, let's continue over here. So what we got is our bond being twisted, and we have our oxygen over here, and then that points this particular ester group up, down over here, and on the other side we have this particular carbon bond over here with the carbon, and in here we have our double bond, and that leads us to our chlorine pointing away with the hydrogen over there, and over here we have a hydrogen, here we have a hydrogen, and here we have a hydrogen, here we have a hydrogen at some point. So therefore a cyclization reaction will happen where this bond will interact with this carbon to form a sigma bond. This bond over here will interact with this carbon to form another sigma bond, and this bond over here will reform a double bond between this carbon and this carbon. Therefore, due to the orbital overlap and the formation of bonds, we arrive at this particular product over here, where the double bond that is now formed is this double bond that is actually formed over here, and these two bonds are actually the interaction between this carbon, that carbon, and this carbon, and that carbon, which is this and that, and this is pointing away, which is that bond being formed over there. So I hope you're able to see this clearly, and how the electron movement is actually involved in the formation of our new bonds over there, and I hope you understand this intramolecular reaction within a particular molecule. All the same, guys, thanks for watching, and please don't forget to hit the like button if you understand it, subscribe to get more info videos, and share with everyone around you. Have a good day, peace, love you all, and be smart.